Okay, we're going to do 2.4, the equation of a circle. So, by the end of today's lesson, you should be able to develop an equation for a circle with center 0, 0, that's the origin, and radius r. You should also be able to determine the radius of a circle with center 0, 0, given its equation. You should be able to write an equation for a circle with center 0, 0, given its radius. And you should be able to sketch the circle given its equation in the form x squared plus y squared equals r squared. So lots going on today. Okay, let's just go over a few key points. The first one's a definition of a circle, really. A circle is the set of all points in a plane that are the same distance from a fixed point, the center. The distance from any point on the circle to the center is called the radius. The distance from any point on the circle to another point on the circle that passes through the center is called the diameter. You know that the diameter is twice the length of the radius. A chord on a circle is a line segment joining any 2 points on the circle. So it doesn't have to go through the center, in other words. If the center of the circle is at the origin 0, 0 of the coordinate plane and the radius is r units, then the distance formula for the radius is just r equals the square root of x squared plus y squared. And therefore, the equation of a circle with center 0, 0 and radius r is x squared plus y squared equals r squared. Okay, so if we just unpack that a little bit, if you know the distance formula, obviously, for the distance between 2 points, but if we've got the distance between this point and this point, this is 0, 0. And if you look at the distance formula, you would just take the square root of x minus 0 squared plus y minus 0 squared. And so that's just x squared plus y squared. Okay, square root of x squared plus y squared is the distance. And the distance here is called the radius for a circle. Okay, and then if I've got that formula, r equals the square root of x squared plus y squared, if I squared both sides, the effect of that would be to get rid of the radical sign here and to square that. So r squared equals then just x squared plus y squared. And this is in fact the equation of a circle. Just like y equals mx plus b is the equation that defines a line, this x squared plus y squared equals r squared is an equation that defines a circle whose center is at 0, 0. Okay. The distance around a circle is called the circumference. You all know that, and you should know the formula for circumference is c equals 2 pi r or c equals pi d. And the formula for the area of a circle is a equals pi r squared. A lot of students get this formula mixed up with the formula for the equation of a circle. And this does not define a circle, a equals pi r squared, but a lot of students think it does, okay, because you've learned about this for so long. But if I wanted you to give me the equation of the circle, you're going to go back to x squared plus y squared equals r squared, okay? All right, let's do some examples here. So it says, write the equation of a circle with center 0, 0 and a radius of 7 units. So equation of a circle, I would write, just like I write y equals mx plus b whenever I'm being asked for the equation of a line, I'm just going to write my general equation out, which is x squared plus y squared equals r squared. So I've taken care of the fact that the center is at 0, 0, because that's the formula that you have to use for that. And if we've got a radius of 7, that means my r is equal to 7, so I'm just going to end up with x squared plus y squared equals 7 squared, and x squared plus y squared equals 49. So normally I would write this down, but it's just, there's no room, okay? You're not going to leave it as 7 squared. You're going to actually square that value, okay? Otherwise it's not complete. So x squared plus y squared equals 49 is the equation of a circle with a radius of 7, whose center is at the origin. If you have a radius of square root of 5, again, I'm going to skip writing the formula down this time. So this is going to be the square root of 5 squared, which is going to be x squared plus y squared equals, I guess I should probably just put that in a bracket, 5. And if you've got a diameter of 10, well, we're really trying to trick you there, right? You know the r is 5. So it would be x squared plus y squared equals 5 squared. I'm not going to bother writing that out. It's 25. Okay, super easy. For the circle, x squared plus y squared equals 36. State the location of the center. Well, another super easy question, because if it's in the form x squared plus y squared, you have to have a center of 0, 0. So the location of the center is at the origin. The radius, well, I know that this is r squared. So if r squared equals 36, then the radius is just the square root of 36, positive square root because it's a distance, and so it's going to be 6. It doesn't say what the units are, so we'll just put the generic old units there. State the diameter, well, that's easy. D equals 2r, oopsie, 2r, so D equals 2 times 6, so of course D is equal to 12 units. And it says graph the circle. Okay, so I know then that my center is at 0, 0, but really that's not part of my graph, right? My graph is my circle, so I don't really need to graph the center. But what I do need to know is that the radius extends from the center to out 6 units. So if I'm here at the center, I'm going out, it's hard for me to see, but I think that's 6. So 1, 2, 3, 4, 5, 6. So there's a point on my circle. 1, 2, 3, 4, 5, 6. There's another point on my circle. So really what I'm doing here is I'm plotting the x and the y intercepts. And for a circle, of course, there's going to be 2 y intercepts and 2 x intercepts. So 1, 2, 3, 4, 5, 6. And of course down 6. 1, 2, 3, 4, 5, 6. Now we don't just join these points, otherwise we'd have a square. But we do want to form a circle. So we could come up with some other points, if you will, that actually satisfy this. So if I looked at x squared plus y squared equals 36, and I went over to say, let me think, what would be a good one? 5, 25, 2, 3, 9. Now, there's probably not a good one, but if I put in 3 here for x, and I solve for y, I'm going to get y squared equals 36 minus 9, and y squared equals 27. So it would be y equals the square root of 27, which is a little more than 5. So my point would be x equals 3, and y is a little more than 5. So I'm not going to bother calculating it, so let's just say it's 5.1. So if I go over to 1, 2, 3 and go up 1, 2, 3, 4, it's a little more than 5. So I could kind of get an idea of the shape of it. You know, I could get a few more points here. But really, once you've got your x and your y intercepts, this is really hard to draw on my tablet. It's hard enough drawing straight lines. You know what? I think that's pretty good. Okay, so there's my circle. I really should just label the intercepts. So this is going to be 6, 0, 0, 6, negative 6, 0, and 0, negative 6. Okay, I should label somewhere x squared plus y squared equals 36 as my equation of my circle as well. Okay, and I mean you don't need to label that 3 and 5.1-ish. It was just the idea is that you can actually put more points on there if you really want to get a better idea of the shape. Okay, a circle has center 0, 0 and passes through the point 5, negative 6. Find the equation of the circle. All right, so again, that's just x squared. I mean, it's super easy to get the equation of a circle. So is equal to r squared. All we know is that the point 5, negative 6 is on there. So we can actually sub that in here for the x and the y. and just calculate the radius. So this is going to be 25 plus 36 equals r squared, and that's 61 equals r squared. And if we go back to our equation, x squared plus y squared equals r squared, I found out what the r squared is. I don't really need the radius for the equation of the circle, so I'm not going to bother because it doesn't come out to a nice number anyway. All I need is the radius squared. So x squared plus y squared equals 61 is the equation. I'm just going to write that as a conclusion. So is the equation of the circle passing through the point 5, -6. Okay, so let's just go back and make sure I did that properly. 5 squared is 25, -6 times -6, 36. Add those together, that gives you 61. And then you put it back into the equation. So this is where I find students do all this work and then they forget to answer the question, which is, what is the equation? It didn't ask for the radius. Okay, what are the coordinates of the other end point of the diameter that passes through 5, -6? So if you've got this circle and you've got the point 5, let's see if this is 0, 0. It's going to be over here and down here somewhere. So let's just say it's there. So this is 5, -6. So we've got the center, we're going through the center, and we're being asked to find these coordinates right here. Pardon my drawing. Okay, so really, what is this question really asking you for? It's asking you to figure out, given that you know the midpoint of this line segment is 0, 0, it's asking you to use the midpoint formula to find x, y. So we know that the midpoint is 0, 0, so I could just say something like m0, 0 is equal to x plus 5, comma, divided by 2, midpoint formula, average of the two coordinates, and then minus, so y minus 6 divided by 2. So we're adding these two together, we're adding these two together, and dividing by 2. Okay, so I know that this has to come out to 0, right? The midpoint is 0, and I know that this has to come out to 0 as well. So I can just separate this now and just say, okay, x plus 5 over 2 has to equal 0. Cross multiply, and you get x plus 5 equals 0, so x equals -5. And I could repeat that for y. Cross multiply again, and I would get y minus 6 equals 0, and y equals 6. Okay, so what are the coordinates? You could say therefore -5, 6 are the coordinates of the other endpoint. Okay? All right. Not a lot of room there to do that work. What is the distance around the circle? Well, of course, that's asking for circumference, so it's asking you to use the formula C equals 2 pi r or equals pi d. So we're talking about this circle here that has a radius of the square root of 61. Okay, so maybe I'll just write that down here. So we've got this. We've got also that the radius is equal to the square root of 61. So C is going to equal 2 times pi times the square root of 61. That would be an exact answer. I'm just going to pull out my calculator here and see if I have a calculator. See if I can come up with an approximate answer. So, I'd like you to use your calculator pi for that, please. I'm just going to find it on my calculator. Sorry, using a new calculator. Times 61 square root. So I'm thinking it's 49.07. Let me just think about that one, whether that makes any sense. So I'm going to give it the answer rounded to 2 decimal places. So approximately 49.07. And again, it doesn't say what our units are, so I'm just going to use the generic units. Therefore, the distance around the circle is about 49.07 units. Okay, does that make sense? The square root of 61 is greater than 7. 7 times 2 is 14. 14 times 3 is 42. So yeah, it's going to be approximately 49.07 units. Okay, what is the area of the circle? Well, that's the area formula. A equals pi r squared. Remember, that's not the equation of a circle. So area is going to equal pi. We know that r squared is 61. So the area is equal to, we wouldn't write it like that. We would put the coefficient in front of the pi symbol. So that's going to be 61 pi. And our units here would be units squared. So we'll just say the area of the circle is, oh, and I forgot my, oh yeah, is 61 pi units squared. I should say that that's the exact answer because I didn't approximate pi. This one I approximated pi. I calculated the number. I tend to leave them when they're nice whole numbers like this, but we could have just stuck that in our calculator as well and just figured out what 61 times pi is. So it's 191.64 approximately. So I could say A is approximately 191.64 units squared. So this would be the exact answer here. This would be our exact answer here, or the approximate answer. Okay, so sometimes I'll ask for the approximate, sometimes I'll ask for the exact. Okay, determine if the following points are on, inside, or outside circle x squared plus y squared equals the square root of 60. So if I know what the radius is, then I can square that and I can compare it to this, right? That's the idea. And then if this value is less than this, then I know that this is inside the circle because this distance, this radius, wouldn't extend as far as this one. And so let's go ahead and find out what r is. So if we have x squared plus y squared equals r squared, and then we're putting in minus 5, I think we already did this one, plus minus 6 equals r squared. So this is 25 plus 36 equals r squared. So r squared is equal to 61. And I know that r squared is 60. Therefore, this one is outside. So we'll just say r squared is greater than 60. So outside the circle. Negative 7 and 3, I'm just going to stick in negative 7 squared plus, no, I didn't need a bracket there, sorry, equals r squared. Oh, I'm making a mess. So this is 49 plus 9 equals, that's an r squared there, guys. Let me just fix that. Okay. So that's r 49. There we go. And this one is going to be 58. This one is less than 60, so r squared is less than 60, so it is inside. And last one, 6 squared plus minus square root of 24 squared equals r squared. So this is going to be 36 plus 24 is equal to r squared. Just get rid of the square root sign when you square a radical. And when what do we get? We get 60 equals r squared. R squared equals 60. So point is on the circle. Okay. A stone is dropped into a pond and sends out a ripple whose radius increases by 5 centimeters per second. Find the equation of the circle 12 seconds after the stone is dropped. And we've got this hint here that distance equals speed times time. So I always, whenever I have one of these questions, I draw myself my little triangle. D, S, T, and we know that distance is speed times time, or time is distance divided by speed, or speed is distance divided by time. All right, so think about a circle. We call those concentric circles. If we've got these ripples, this is not easy on this tablet. So we've got this stone that was dropped, and we've got these concentric circles. Oh boy. And the ripple's just getting bigger and bigger. So we know that that wave, that ripple, is traveling at a certain speed, and that it will be at a certain place after 12 seconds. So what we want to do is figure out what the length of that radius is after 12 seconds. So we're going to say the distance is speed times time, and the distance, which is really the radius, is going to be the speed at which that wave is traveling, so 5, times the time, which is 12. So the distance is 60, and we look at the time, the distance, speed, is in centimeters per second, so this distance is centimeters. Okay, so that's the length of the radius. That's not the equation of the circle. So the equation of the circle is x squared plus y squared equals r squared. And we will figure out what our r is. So that's going to be x squared plus y squared. We've already figured out our distance. That's our radius. So it's going to be 60 squared. We're not going to leave it like that. We're actually going to square the 60. So that's 3,600. Okay. Therefore, the equation of the circle 12 seconds after the stone is dropped is x squared plus y squared equals 3,600, right? It's the equation of this circle here on the outside with radius 60. Okay. Wow, another one. Given the circle defined by x squared plus y squared equals 25, graph the circle. Verify algebraically that the line segment joining A and B is a chord on this circle. Determine the equation for the right bisector of the chord AB. And do I have a graph here? Let's just see. Oh, verify that the right bisector passes through the center of the circle. Well, that's not a very good looking graph there because I can't even tell where the axes are. So I'm just going to pause the video and I'm going to put a better one on. Okay, that's better. So x squared plus y squared equals 25. Our r squared is 25, so our r is obviously 5. So we're going to go plot that point there, that point there, that point there. Remember, this is an equation of a circle at the center because it's x squared plus y squared. And then I'm just going to do my best. I bet you could do a lot better. There we go. Okay, so if I were labeling this for on a quiz, I would expect you to put the intercepts in and the equation on there. But let's just have a peek at what we have to do here. So graph the circle. I'll label it after. Verify algebraically that the line segment joining A, negative 3, 4. So I'm going to go negative 3, 1, 2, 3, 1, 2, 3, 4. So right there. And negative 4, negative 3. So this is 1, 2, 3, 4, 1, 2, 3. So it's saying verify algebraically that the line, see, look at that, that's just not good. Let's do that again. Very hard to draw lines. You know what, I'm just going to use my line tool. Sorry, it'll take me a second. Okay, so I've got this line that's joining those points on the circle. So now, verify algebraically that the line segment joining AB is a chord on this circle. Okay, so I need to prove that, because the definition of a chord, is that it's a line segment that joins 2 points on a circle. I need to verify that the point A, negative 3, 4 is a point on this circle, and that this is a point on this circle. I can see from my graph that it looks like it, right? It looks like it, but I can't trust a graph. I'm going to verify that algebraically. So x squared plus y squared equals r squared. I'm going to sub this point in, so negative 3 squared plus 4 squared. That has to equal 25, okay? So I'll just put that in. 9 plus 16 equals 25. 25 equals 25, and left side equals right side. Okay, so I know that this is a point on the circle because it satisfies this equation. Okay, and then the other one, I'll just start again with the equation of the circle. I'm going to put in negative 4 and square it, plus 3 squared equals r, not equals r squared, equals 25. So that's the left side of this. 16 plus 9 equals 25. 25 equals 25, and left side equals right side again. Therefore, A, negative 3, 4, and B, negative 4, negative 3 are points on the circle x squared plus y squared equals 25. So AB is a chord of the circle, or on the circle. Okay. Determine an equation for the right bisector of the chord AB. So if we go back down to our little diagram, and I'll just do this in another color. Remember the definition of perpendicular bisector of a line segment. So I'm looking for the line that bisects this line, so I'll just say it's like that, and that passes through this line segment at a 90-degree angle. So something like that. So this is the perpendicular bisector, and this is 90 degrees, and this is bisected. Okay, so if I need the equation of that perpendicular bisector, what I need is the slope of the 2 points of the line that joins these 2 points. So I'm just trying to remember, this was negative 3, 4, I think that was A, and B down here was negative 4, negative 3. I'm just going to verify that. Okay, so then I need to find the slope of this line I need to find the negative reciprocal of the slope of that line to find the slope of this line. Once I have the slope of this line, I substitute any point on this line. We only know one. That's the midpoint in to find the equation of the right bisector. Okay, so first thing I'm going to do is I'll find the slope of AB. So that's going to be 4 minus 3. Let me just double check that. So 4 minus 3 over minus 3 minus 4. Yikes. That's going to equal 7 over 1, which is 7, which is a pretty steep slope, and it looks like it's a pretty steep slope. So I'm comfortable with that, and it looks positive. So the slope of AB is that. The slope of the perpendicular line to it is negative 1 over 7. Negative reciprocal. Flip that, take the negative of it. Okay, so now I have my slope of my perpendicular bisector, and I need to sub in a point. I've got y equals negative 1/2 x plus b. That's the equation so far. I just need now to find my b by subbing in a point. Well, the first thing I want to do is find the midpoint, so I'll just find the midpoint of AB. You're using capital M here, so that's going to be equal to negative 3 minus 4 all over 2, and then 4 minus 3 all over 2. Okay, this is going to be negative 7 over 2, and this is 1 over 2. Just to quickly verify that. So negative 3 minus 4, so I'm adding these two together. Negative 3 minus 4 over 2, and 4 plus negative 3 is 4 minus 3 over 2. Okay. So now I'm going to sub negative 7 halves and 1/2 into y equals negative 1/7 x plus b. So when I do that, I'll do it up here, I'm going to get, let's just y equals negative 1/7 x plus b. I'm subbing in a half here for y. And I'm subbing in negative 7 halves here for x plus b. Okay, when I multiply these two fractions, the 7's cancel, and I end up with, I believe, 1/2 plus b. And when I rearrange, I get 0. Let's just have a quick peek here. Does it look like my y-intercept might be 0? Does it look like this perpendicular bisector is crossing the y-axis at 0? Yeah, it could be. So, therefore, the equation of the, I'm just going to call it right bisector because it's shorter, is y equals negative 1/7 x, and then we don't write the plus 0. Okay. All right, so the last part, verify that the right bisector passes through the center of the circle. Well, interesting. So what we want to do here is, let's see, we've already ascertained that this right bisector has a y-intercept of 0, and that is the center of the circle, right? So really all we need to do here is sub in the 0, 0, which is the coordinates of the center of the circle, into our equation to see if left side equals right side. So 0 equals negative 1/2 times 0. 0 equals 0. Left side equals right side. So if we had another equation here, like plus 1, or we had something else, when we sub in 0, 0, it would not be on the equation of that perpendicular bisector. It wouldn't work out to left side equals right side. There's probably other ways that you can do that, but this is pretty simple. So therefore, the right bisector passes through the center of the circle. Okay, I think that's all. Let me just double check the next page. Yay, okay, that's it. So you can get started on your homework. Thanks very much for listening.